Okay, intro to parametric modeling. And this is also in disguise an intro to Grasshopper at the same time, because that's sort of the standard that we're using. My thing just said it and it is unstable. So that's me and Jonathan. And here's generally the concepts we want to look over. We want to look over visual scripting, and these terms don't mean much right now. Visual scripting, associative modeling, patterning, data structure, modules, and advanced control, and other things, responsive modeling, analysis, feedback, interoperability. We'll touch on all these things. One main point is we got 2 hours, is that right? Yeah. It's not enough time to learn anything really, but you can learn to be comfortable enough with the interface and with the tool and know some fundamental concepts enough that it'll get you going to do your own thing. That's the biggest goal to leave here with, because there's that just initial hump of like intimidation, right, of not knowing what you're looking at, and us going through stuff together will get you over that hump, and then you can learn on your own. And honestly, you don't, in my opinion, you don't learn stuff from workshops like these. You learn it from doing it. You've got to have a project or some intent. You don't learn stuff from following tutorials unless you have a specific reason to do it because you're trying to solve something. You got to be trying to solve problems, trying to apply these kinds of things in your own work or at home, and this helps you get started with that and gives you an idea of what's possible. Though of course I can't cover everything. I teach entire like college-length courses on computational design, and so here we got 2 hours to just touch on some subjects and do some things together. All right, so let's start with this. Let's start with visual scripting. So if we look at, where's my Rhino? If we look at Grasshopper, so as we know, it's plug into Rhino, so everyone should have theirs open soon. I'll give you, while mine's loading, I'll give you a second to load yours. So you can see all my plugins are coming in that you may not have. And so for 6, it's now standard, but it was started, 9 years ago or so, and it was kind of very alpha, and was an add-on. Anyway, so here's your interface. If you're not familiar with it, this is what you're calling your canvas, and then here's all your components that you put together into some string. Like, let me just show you. You don't have to do this. Like, here's parametrics in its essential form. I put 2 things together and get a result, and so these wires are connecting them, and there's sort of data flow from left to right. And in fact, you kind of get even though it's not left to right, you see the wires are sort of implying that they're going this way into this direction. You think they should have sort of like an arrow. Anyways, so here's a result of those 2, and now here's the concept of parametric design. Everything you did in the past is still accessible at any given time, so I can still change the parameters that I use to make that. So you can see the result is varying. And that's really important and really powerful when you get into modeling, because then everything you've done in the past, as opposed to typical manual modeling, when you do something, typically it's fixed and you're building off of that, and everything you've done beforehand is fixed. Now, with parametric modeling, everything is flexible and based on quote-unquote parameters, so you can play around. The whole design process, or the whole modeling process, is flexible throughout, and that has many powerful ramifications down the line. So real quick. Visual scripting. What scripting is really just coding. It's basically coding in a native environment. It looks like code. We are doing this. We're essentially doing this, where instead of we write for and then give it the input, we've got a little button that says for and have a little input that, though, I say that, and I don't mean that exactly. We don't have loops like this, and that's the hardest thing to learn about visual scripting, is the way that we deal with loops and data structure and repetition, which we'll get into slightly. Yeah, I was worried about my audio.
It like comes in and out. It's not all.
No. I'll talk slower, maybe. Yeah. I don't know. Shoot. I was worried this would be a problem. like right around the time of day when I think everyone's like, the schools all go nuts. So you can think of that modeling process laid out there in time as a sort of choreography or a set of steps. And that's what we're doing in Grasshopper, is we're laying down a set of steps. So in this case, it's one step, but you could do another one, you know, multiplication, multiplication, and there's step 2. And now you get the sense that here's like 2 steps in a series of steps. And at any given point, they're all still available for you to adjust. They're all parameters that are adjustable. So you're seeing the whole choreography, the whole description laid out there in front of you. It's sort of like choreography as well. And just to point out, to help you conceptually, Excel is the original, the OG parametric software. It's original, it's basic parameters that relate to other things that are part of calculations, and you can go back and change the original parameters, and that affects the whole thing down the line, right? This is when you turn on association, what's it called, dependencies. So these are all depend on that original parameter. So you got it. Excel is parametric modeling, essentially. We're just doing it with geometry. The original one was Max MSP. I'm not going to get into this. It's a lot like electrical diagrams. The original architecture one was generative components. Not going to get into this. And then it's proliferated everywhere. Now everybody uses visual scripting. I'm going to skip all that. Okay. Associative modeling. So this is the foundation of parametric modeling. Looking at your audio. Okay. I hope it isn't too bad. Let me know if it gets worse or if you missed something, please. Oh boy. Okay, associative modeling. So first thing we want to do is try, we're going to do this. I'll come back to this. Let's do something first here. There's a few concepts to get into, and I'm going to share this script with you later. So I'll just label it for us all. So this is I don't know, parametrics intro. Let's call that. Okay, starting down here. So we're starting with, let's do this together now. Okay, so here's the first concept. Here's the first concept to learn, is that things that are in Rhino aren't necessarily in Grasshopper, and vice versa. There's sometimes a step in between to link them. And that there's reasons for that, but we don't need to get into that. Yeah, so so first of all, it's useful if we're all in the same units. I'm in feet right now. I might want to stay in that for all of us, so that our units are similar. That's just helpful. Second, I'll set my screen up like this. Hopefully you guys have 2 screens so you can see what I'm doing on one screen and do your own thing on the other. And for the screen that is just you, I would set it up like this, and I would change this to hit the drop down and go to set view and go to perspective. And I would just look at just the perspective over here. And okay, so I want to get.
You're here. Look at this. Sandhya was looking for you.
Really? Hey, Juan, you might want to turn your.
For what?
Juan, you might want to turn your sound off.
Just to take a look at you.
Shannon, there you go. Great. Okay. So if I were to draw a curve in here, let's all draw this curve. I'll just draw like a NURBS curve on the ground here. That curve, Grasshopper doesn't know about it yet. So to get them linked, we've got to use one of these components to get it linked. Okay, so let's talk about components. I've got this guy in the way. Let's talk about how this all works. Under all these tabs are all your options for components, and when you touch them, click on them, you can drop them. So you can click and drop it into the canvas. These are all organized fairly well, so you can see it's like these are yours are probably more readable than mine. These are params. It usually has to do with inputs. As like we were saying, parameters are the things that you can adjust. And that could include lots of geometry that's coming from Rhino. So all this stuff that's the black hexagons, they're usually things that you're bringing in from Rhino, or they sort of store input elements. And then there's other kinds of inputs like all these sliders and buttons and graphs and things. We'll get into a few of those later. And then here's the math stuff. Here's sets. This is the data structure stuff that I'll talk about a little bit later. Vectors and points, curves. So here's your kind of geometry stuff. All the curve stuff you want to do is here. And it's really useful before you know what you're doing to sort of peruse these things and look at what's possible to get a sense of what you can do and what's available, what it has. And then they're fairly well organized. So like, things under analysis are helping you query a curve. Division is straightforward. Primitive is usually what is building one in a simple way. Spline is a more complicated building and doing things within there. And sometimes I have things that came from other components and they sneakily drop it in the main folders or tabs, which is really unfortunate because I can't tell then which ones you have and which ones you don't. I'm pretty sure this one came from pufferfish and you don't have this. Anyways, that shouldn't be an issue later. Surfaces, meshes, intersection has its own whole tab. There's a whole thing, right? And that's actually another thing that's harder in parametrics than it is in modeling, because trimming and slicing and splitting is easier in manual modeling than it is in parametrics when you're sort of teaching, talking about instructions and explicit things, transforming, right? And then there's display, and then I have all these are all the extra plugins that I play with. You should have Lunchbox. We're going to use that, and then you should have TT Tools. We're going to use that as well. Okay, so once I know I generally know what is available, though I still discover stuff every day, but my normal approach to getting a component when I know what it is I double click on the canvas and I type it in. And for instance, I want to get a curve from Rhino into Grasshopper. I know it's one of those black hexagons. I know it's under params. It's probably called curve. If I type in curve, it's there. It's the bottom one, but it may not always be the bottom one. You might have to look through. And even doing this helps you understand what's available. Like, what is all this stuff? We've got curve pull. That sounds interesting. Create curve. Doesn't sound like what it is. It might be just part of some other weird component. Yeah, so let's do that. And then, so here's the process of getting it into Rhino, into Grasshopper. You're going to right click on that curve. You're going to go set one curve and grab that guy. So now we've got a curve in Grasshopper. So when I select this, you can see it turn green. And in fact, if I hide this in Rhino, it's still there in Grasshopper. And just to show you, you don't have to do this. When I move it, you can see that something's happened in Grasshopper. Okay, so let's go back to what I want to do. So we want to make an associative geometry. We're going to do a lofted geometry. Lofted being like these kinds of forms are what you would do to loft. Like you can see each section of this tower sort of just defines its curvature. Crazy building like Sumaya would be made with like a loft from the bottom to the top, and you twist and have a smaller one in between. You can imagine this could pretty much be done with 3 curves if you do this right now. That form. It's originally from boat building, where you make the ribs and then you loft the stringers and then you make all the intermediate ribs. That's what the term comes from, is lofting these stringer lines. So it's really a naval thing. And in fact, Rhino is like the #1 software for naval architects for designing. Yeah, okay, so curves. Okay, so let's make something similar sort of to Sumaya. Well, you can do whatever you want. I got this curve. Oops, I hit it. And I'm just going to copy it up. And I like to use the, what's it called? Powerball? Gumball, sorry, gumball. And I'll just if you select it and you have your gumball on down here at the bottom. I don't know if you guys are new to Rhino as well, but gumball's new as of Rhino 6, I think. Super cool. It's just basically copied it from Maya. I'll just copy this up. I'll hold down Alt and I'll drag it. And I'll drag it again. And so there I've got the 3. And if I want to do something like sort of Sumaya-ish, I can shrink the 1. That's by grabbing these little things. You can rotate them. But here, let's get into this in a second. So you want to get those three curves. So first of all, what do we want to do? We want to do a loft. I can show you what that looks like in Rhino. I have straight sections on. So it's often helpful to test what you're doing in normal modeling if that's what you're used to. Okay, so let's say I wanted to do that. If I want to do that in Grasshopper, usually often the command is the same. There are, let's say, 15 to 20% of the time, it's actually a different command name for some reason or another. Like that's true of, for instance, what we call here is planar surface. In here, it's called boundary surface. That's just like you got to ask David Rutten about that. Why one is different than the other. David Rutten's the creator of Grasshopper. Maybe he thought that made more sense. Anyways, we want to do lofting. So if I double click and I say loft, it's the first one that comes up. There's these other things, but probably want to go with the simplest one. So it wants curves. So, okay, so here now let's get into the structure of components. They've got inputs and outputs. That's pretty clear, right? Left to right. What's really useful is hovering over these inputs and outputs because they tell you, one, what they want. The inputs will tell you what they want. They'll also tell you what you're giving it. Once you do it, it tells you what you're giving it. So it says it wants section curves and wants them as curved. That's the black hexagon thing at the top. And then at the bottom it says what it's gotten. And it says it's gotten one value inherited from one source, and it's a referenced periodic planar curve. Periodic meaning that it's closed. So it tells you what it's got already, and it's just got one thing. So what's coming out is null, nothing. The resulting loft surface is nothing. Is it because I didn't give it enough stuff? Here, now we're going to kind of error, what's the word? Debug what we've done, or error track. Errors are useful. If it really, this should really actually have a full error that would pop up right here. It says, give you a warning or something, or it would turn red. Instead, it's just failed, which hasn't really told us anything. Am I missing an input? What's this? This wants loft options in the form of an options. No, that's not it. Actually, I think it's because I only gave it one curve, right? You need at least more than one curve to loft. So if I want to get more than one curve, we can do that in the one component. You don't have to do multiple components. You can do it all in one. And there's lots of ways to do this to get curves into, like things in from Rhino to Grasshopper. At least there's maybe 5 main ones, but I almost always use these black hexagons. So I can right click on this curve and I can say, instead of the set one, I can do set multiple. So if you do set multiple, you can click these, and I'm going to do it wrong first and show you that I click them out. The order that you click. A big box, it will use what's called the drawing order, which means sort of whenever you touch the last one. But that's not something you want to rely on. If you need these things to be in order, you either need to select them yourself or you need to sort them later, which is also not a big problem. There's lots of sorting tools, like sort points, but you could sort a point that you make from sort curves along curve. That's actually a TT tools component. So if I press, you don't have to do this, but if I press Control Alt and click on it, it tells you where it came from, and it's coming from TT tools. So if I put a line here, you don't have to do this. If I put a line here that's vertical, like generally vertical, and use that as my sorter, this will sort the curves. Even though they're already in order, it'll sort them in order. This doesn't help because they're already in order, but let's say I move this one down. It's now switched the order and it's figured out that I want that one there. So if I move this up now, it's all fine. Okay, so there's the building. So here's the beauty of parametrics and associative geometry. The loft is now associated with these curves. We can play with these curves as much as we want and affect the final loft. And that's just the beginning. We can do so much more with the loft now. And that's what we're going to get into next. We can make patterns on it and do other things and cut floors and do so much more. So everything that we've started with is still available to us. That's the beauty of parametric design. I'll leave this in here just for the hell of it, but you don't necessarily need the sort curve. But that's useful when you have a lot more stuff to select and you don't want to do it up, one at a time. You want to use parametrics to your advantage. You want to use computation to your advantage. Okay, so where are we? Aha. Are we all caught up with this? Is my sound decent?
Sounds good, yeah.
Okay.
Great. Great. Okay. So next step, what are we doing next? We did our lofting. Patterning is next. That was the next concept we want to look at. Patterning, crazy patterning. There's so much you can do with patterning. We're going to do fairly simple stuff, but the beauty of this is it's such a common architectural problem, the facade, and the facade is such a ripe arena for parametrics that there's a lot of pre-built tools to help us with that. And recently, this is an aside, I just was getting into looking at Parakeet, which is the most insane tool that I've seen so far. Here's just one example. Oh, strange, it's really slow. Where they just do patterning beyond what I could imagine. So I don't know what this is, this Gilbert tessellation, and then they're going to put like that into this hexagon. So they're doing something where they combine different patterns and have one related to the other, independent of the other. And they make it look really fast because they sped up their GIF, but still, it's insane stuff they do with this. I don't even know where I would use this, but I'd like to know that the power is there. And there's a lot more to explore in Parakeet. So if there's ever something you can't accomplish, look around for the tools that are available, because the people have done some pretty crazy stuff and it's almost always free. I have no idea how they did this or what's going on here with the math. Anyways, okay, so patterning. Yeah, okay, so we have our tools available to us. Hopefully you all installed Lunchbox already, which is this guy. Did you install Lunchbox already? And the beauty is Lunchbox is really easy to install because he built in an installer for you. If you don't have that, I'll just really briefly mention how to install other plugins. Sometimes I just give it to you. You know, if it's Food for Rhino, Food for Rhino is the place where all these are stored. All the plugins they live. So for instance, Pufferfish. We'll have holy crap, look at all those components. It will have a download here and it'll be a zip file. I'll even have one for Windows 7. And you want to drop it in this folder, which is special under File, Special Folders, and Components folder. And this is where your libraries your components will live, your plugins. There's some other steps. You sometimes have to right-click on them and unblock them. That's a whole other thing, but I'm not going to get into that. But that's a start on how to install components. But Lunchbox does it for you. I don't think TT Tool does, but hopefully you figured it out. So Lunchbox, what does it have? Lunchbox is the kind of gold standard. It's got all the stuff that is practically stuff that could be native to Grasshopper. It's such standard stuff that you use all the time, especially the paneling, like all these triangular panels, diagonal panels, hexagon panels. It's such a kind of common problem. So paneling is what we're going to play with now. We want to do this sort of patterning, though you can do structure as well, but I just want to do some sort of basic facade stuff. So let's grab one of these. It could be anything. Maybe I'll do hexagons just for fun. That's just because we got Sumaya on the mind. That's hexagons, right? And so, okay, so we've got, if I grab that under panels, hexagons, what does it have? What does it want? It wants, if you hover over the inputs, it wants surfaces to panelize, the surface to panelize. It wants the divisions in U direction, in V direction, and then what's T? Transform the angle. Oh, that might be like the proportion of the hexagon or something. I don't think I ever played with that, but we can try that, see what it does. So what do we have for surface? We have this thing, there's an untrimmed surface. So if I plug that into there, we should get something to start off with. Looks like it's done something that's nowhere near what I want it to look like, but it's probably because I haven't done the other stuff. Okay, how do I put in numbers to this? You saw me do it quickly here, but I didn't really explain it. That's another thing that's under inputs, and it's one of these sliders. You can grab a slider just like that, but I like to do it the easier way, which is I'll double click on the canvas, and now you can type in the start and the stop of your slider, like where it should begin and where it should end, and that'll make the slider for you already. So like I have a guess that I'm going to want somewhere between 10 and 50 cells. So I'll say 10 and then say dot dot and then 50. And you can add decimals to that as well, but in this case we don't want decimals. So 10 dot dot 50, double click on the canvas, 10 dot dot 50. That'll make your slider. So if I put that into one of these, so if you haven't figured out how to plug things in yet, you're going to grab the node. You're going to grab the node from the input and put in the output. You can go backwards too if you want. I didn't mean to do that backwards one. So now I have at least one direction is parametric. That's great. So everything's still parametric. I can still move everything around, and the hexagons follow and the loft follows. So we're fully into parametric modeling now, which is amazing. Okay, so there's one direction. I want to do another direction. You can copy paste, just Control V or Control C, Control V. Or I like to do this cool trick where you start to drag it, and then you press Alt. So you have to start dragging, and then you press Alt, and it'll copy another one for you. I really like that. It's super fast once you get used to it. If you press Alt before dragging it, it does this weird like warping space and time thing on your canvas, which can be useful when you get a really complex canvas. But I'll just do the drag and then press Alt and copy it. That's a really fast way to do it. So I can plug that into my V, and now I can affect this direction and get this to look a little more like proportions that I want. I can go even denser if I want. And it looks like I've run out of limit on my 50 here, and maybe I was wrong in the beginning. I want to add to that. You can right click on the gray part, or you can double click on you can right click on light gray, or you can double click on dark gray. There's two different ways. I'll right click on gray, I'll go to values, and then you have these values here. You can do this. This is like a weird interface. You can like drag the numbers like it's like a slot machine, or you can double click on the whole thing and type in a number. So what if I said like 100 and then press the green check and the green check, and now it goes all the way to 100. So that's, we got a little more flexibility there. You don't want to get too dense. You're going to start slowing down your computer later down the line as we do more complex things. So I'll keep it like somewhere reasonable. And then I've never played with this T. While we're here, I'm just going to try it. Let's see if I did 2.5. What happens when you play with the T? Dun, 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 dun. Whoa. Look at that. We're like Parakeet. We can make our own stuff. So I guess it changes that, the kind of inverse angles. Whoa, that's cool. So you actually, in one component, have 2 or 3 different components, and then you got that diagonal, you got that triangulation, or you got hexagons, or you got this crazy zigzaggy guy. I've never played with that. That's cool. I like that. Okay, I probably have played with that. I just forget things. Okay, patterning. Is that all we were going to talk about with patterning? Yeah. Okay. So now we're getting into some real stuff. This is the hardest part about. I just want to show you this. You don't have to do it. Here's the hardest part about parametric modeling, especially in Grasshopper. And in case you are worried or decide that you hate Grasshopper, let me assure you that it's way worse in Dynamo. The only thing it's better in is scripting. In my opinion, code deals with sets and loops and arrays better than visual scripting. That's kind of the difficulty is because we're looking at this linear thing, and yet it's doing things many, many times. Like this component is actually working many, many times, but we're just seeing it once, right? So it's sort of like in its black box, is it repeating itself? And it's repeating itself by the times that we've told it to, 23 by 61, essentially. That's how many times it's repeating itself. No, it's not exactly right? It's because these are offsets, so there's probably like, it's not quite that number. But so now I want to show you, this is an important thing to recognize, is a hint about how many times something is repeating itself and how many items are flowing through the canvas, is to look at these lines. These lines have a shape to them for a reason. This double line means that there's a bunch of things in it. The single line means there's only one thing in it. So from this output, this untrimmed surface, we've got just the single surface coming out. From this one, we've got, if you hover over it, we've got 744 polygon curves coming out. So we've got this double line, like double line. And then there's one more form, which I will show you now, which I'm going to go through this real quick, is dotted, which is a third data structure, or another data structure, which is called a data tree, which is like a level up in complexity, and we're going to get into that in a little bit. It's going to take some explaining, and this is the hardest thing to get used to, in my opinion. But you will eventually get it. You won't get it today, but you'll get it from using it, and hopefully I'll get you comfortable with the idea and the fundamentals of it. So what do we want to do? Okay, so let's do some things with data structure. Okay, if I want to do, let's do something simple to this module. I want to do something very simple. Okay, so now we're getting into the concept of a module. Like, here's what I want to talk about before we get into data structures. We want to do something to each of these panels as if they're individual things. And the interesting thing is, Grasshopper will treat them as individual things, just the way they do, like with this component. It's one component that's doing many things. We can make one component that's doing one thing to many things. So it's not, if I want to do something like, I want to take this component, no matter what shape it is, and I want to say, let's say, scale it by its center. I want to do that. Can I do that with the Alt? Something like that. And I want that for that to vary. And no matter what the shape is, it should do the same thing. As in, I'll take the center point and I'll scale it. And it is useful to do it manually sometimes in Rhino, just to get a sense of what you want to happen. Like, for instance, if you're going to do something even more complicated, like I want to draw some shapes and I want to, like, move them up or something, that's really useful to test in Rhino to see what's happening. Like, okay, it's moving up in this direction, it's using that point, blah, blah, blah. It's nice to test it manually if you're not used to Grasshopper yet. So I'm jumping around in my presentation here, but if we want to do something eventually like, say, like this, expand that. Like this facade, this would be a more complicated one, kind of what I was alluding to, or like this one if we'd done diamonds, where the on the upper right, where we just change the scale of the inner thing. In this case, the inner thing is a negative. We'll make the inner thing a positive or whatever we do. Yeah, actually we can do it like this. It's easy too. Like if we wanted to do this thing, we'd be scaling the inner guy in and out, and the outside part would, like, we'd make a loft between the two, and can't quite see that's a surface. That would scale in and out, and there'd be our surface, and then we'd result in this kind of thing, right? And in fact, here's a concept that I also wanted to just really briefly touch on. If you use record history, this is the original Grasshopper. This is what Jamie Bratton started making. It was called explicit history, whereas it's the same concept. Whatever you've done in the past is still remembered and still flexible. So if record history is on and I do my loft, now if I move this I always mess this up, but if I move this, the loft should follow. Yes. So now I'm basically doing parametric modeling in just Rhino with no Grasshopper using explicit history. That's what we're doing in Grasshopper, only even better, we can see the whole history laid out in front of us. So explicit history, record history turned into this. So I want to do this and have it vary for each one. If you wanted to get crazy, you can move it out or something, but we don't need to go that far. That looks like a chameleon eye or something. Okay, so there's my test thing. If I just want to scale these, how do I scale them? This thing had, what do we have for scale? That's under transform and probably Euclidean, maybe not. Morph, affine. Okay, affine. I don't know all these words. They seem like they're mostly French. Morphological. Scale, there's a few different scales. There's scale non-uniform, which is kind of cool because you can do, you know, like this one would be, if you just did it, if you stretched it, you could do it that way. So that's non-uniform. It probably gives you the 3 different dimensions. I thought there were other scales, but maybe just this one. So if we use scale, because that's what we're doing, what does it want? It wants the original geometry, the base geometry. It wants a center point for scaling. And in fact, in this case, it has one set as default. That, remember we were talking about the inputs you can see there? It's already got an input, which is 0, 0, 0, which is the origin, right? And then what does it want? It wants a factor. That makes sense. How much do you scale it by? So the center of the scaling and this how much you scale it by. Where this if you, because I'm using the gumball, it's not as clear. But if I had done scale with the Rhino command, you would have gotten those same questions. If I say scale, it says ask me for the base point. I'm going to choose the center, and then ask me for the factor, which can be a number or it can be like you can sort of make a representation out of curves, right? If you've ever used that. And look, my loft is still stuck. It's still linked. Okay, so we need center point. We need a factor. This is great. This component's really nice because it made our center points already for us. That's what this, we're seeing them on the canvas there, the dots, and it's got them out here with us, and it matches. It's giving us this list of 744 polygon curves, or whatever your number is, and 744 centers, and they happen to be the same and they correspond with each other. I know that sounds obvious, but it's important to make sure you have, if you're going to put in 2 different lists, so let's say I'm putting in my, it asks for all the geometry to go in there. It asks for base geometry, so I'm plugging in my base geometry, that's my cell, and I'm treating it like an individual thing. I want my cell, and I want to use its center point. And here's that center point, and it happens to be the same length of list, and that's really important. So they align. We know that they align. We know that the first object here is the first object here, and I can just check that. You don't have to do that. Just going to show you this. This is a whole other set of components that you don't need to get into quite so much today, but we'll do a little bit of it if I turn this off. And so this is grabbing, this is a list item. It's grabbing the first item, the 0 item of this list, and it's turned green somewhere. I'm going to find it. There it is. And unfortunately, it's a half a hexagon, whatever. That's fine. And it's actually not even a center point. I could change that. I could say, give me like the 4th one, just so it's like a regular hexagon, or it might be somewhere further down the line. We have to go to like 20 or something, so it's not on the edge. I don't know. Doesn't matter. It'll work either way. Where'd it go? Just want to show you this. Whatever. We're still on the edge. Doesn't matter. Okay, so I've got the 1. I've got the 1. I'll put them into here, and now turn scale back on. It's scaled just the 1. That's how we want to think about the whole thing. We can do it like this to start off with conceptually if we want, or we can do them all together, but you want to think of them as individual objects, and whatever rules you give it to do, it can work on all the objects in the same way. So the logic should apply to everything. And in this case, I got lucky that even though it's a different sort of module, the logic still sort of applies in that the center point is still somewhat near the center, and it still scales it, even though it's not really a hexagon. It's whatever that is, a quadrilateral or a rhombus. I don't know what that is. I forgot my terms. Okay, so let's plug this back in. That's how we had it before. Maybe, hopefully you guys didn't do what I was doing. Okay, so it scaled all of them. That's cool. It scaled them all by the same amount, because the factor already had a default to 0.5. If I if I made a slider for that, I could scale them all differently. Let's make a slider. If I just double click on the canvas and actually type in 0.5, it's actually going to give me like a nice slider that's from 0 to 1. That's pretty cool. Actually, I can just use that. And then I can just like slide up and down here and make them all vary. And then the last step that I haven't done is the lofting them, and that's where it's going to get complicated. Let's not do that quite yet. I want to do one more thing first. I want to scale them all by a different amount. So like we had a list of geometry, we had a list of center points that are all different. We don't have a list of factors that are all different. All the factors are the same. Let's pause for a second as well. A couple things here. We still have, when I talked about the whole history of the design process, it's all still laid out and it's all still visible on the canvas, so we're all seeing it all, and that can get cluttered after a while. So it's useful to go back and start turning things off visually so you can see what you're doing. So I'll go back and turn off some of these things. There's like 5 different ways to do that. You can select them all. You can right click on the canvas and say preview off. You can select them all and say Control Q. That'll toggle them. So if some of them are off, it'll turn them on. But in this case, they were all off. You can also middle mouse button and do the blindfold guy. You can do them individually and say preview. Anyway, so I want to turn those off. That way I can see just kind of what I've done so far, which is the scaling. And it's all I'm also seeing my cells here, which are the original ones. So if I turn the original ones off, I can see only the final ones. So I like to see the originals too, because those kind of go together, right? Also, point of personal preference, I hate seeing that grid. I'm just going to turn off. That's options, grid, show grid lines, blah, blah, blah. And then personally also, I go through and I take screenshots all the time of stuff that I'm doing that I like, or who knows what. You can also put those on the canvas, like have a little sketch to remind yourself, or I don't do that often enough, but you can put like not that. You can put the image here, and even though this component is meant to be like taking out hue or contrast numbers to use as actual like patterning, which we could do if we wanted to get crazy. You could put like the image here of what it had done at that point. That's a nice way of getting the sort of choreography that I talked about, like this here, there, or there, where you're like actually visually seeing the choreography as opposed to just seeing these big battery things, which can be confusing. Yeah, so scale, that's good. So turn that stuff off. I want to get like a different number for each one. Maybe it's all in like a gradient. So we're trying to work towards this gradient. I won't jump through again like I did before. This kind of gradient thing like this. We're not going to get quite this at this first step, but we can do some sort of gradient. What if we wanted just numbers that are ascending or something? Like a list of numbers. So what do we have for lists of numbers? Under set, under sequence, you've got these different kinds of lists of numbers, character sequence or Fibonacci or range sequence series. The main ones are range and series, and they just do something slightly different. We're going to use range, and I'll explain to you what the two do. So grab range, and then we'll just look into what those do. They're just slightly different. Oops. I have this clever diagram that my colleague made, though it's, I wouldn't say it's the easiest thing to read. Oops, I have this, I lost the other thing. Okay, so series, let's look at the input first. What does range want? It wants a domain, as in where's the beginning, where's the end, and it wants the number of individual steps. So you control the number of steps and it'll divide it for you. Whereas series is the opposite. Series wants, in fact, let's look at it here instead. Series wants, what does it want? It wants the starting point, the step size, and the number of steps. So that's different from opposite from range, because range wants the number of steps and it's going to give you and the ending number, and it's going to divide it for you. Whereas this has an open-ended end number, and it just adds up to whatever it adds up to because you gave it the step size and the number. So those are two different ways of approaching it. In this case, I want to use range because I want to limit the end number. I know what that's going to be. Of course, you could do the math and do that in series 2, but I know I want to end in I know I don't want to scale above 1, but of course you could. If we did that, we'd get this weird pattern where it would like go beyond itself, and then you get some kind of cool thing going on. But if for some reason I want to control that to below 1, I want to use range. So we're going to set a domain. It's already set from 0 to 1, so let's just leave it. That'll save us some time, but you could make a domain. You don't have to do this. Construct domain if you wanted to control that. That's this one. And then the number in between, okay, here's where it gets interesting. I had said that I want a different number for each one of these cells, which means I want a different number, which one's a new number out of range for every one. So I want range to make as many numbers as cells I have. So I want to make 744. Okay, here's the dumb way to do that. I can type in 744 and write that in there and plug this in, and now I get this gradient happening. Okay, that's interesting. That's fine, except I probably did it. It's probably not 74. It's probably 750-45 or something like that, or 743, whatever, because it started at 0. Assume that's what this error is. Oh, it doesn't like scaling by 0. That's fine. Okay, but I want to tell you about why this is dumb and why you want to avoid this. This is not parametric. Do you guys get why that's true? We've just broken the chain of like everything is adjustable and everything is flexible, because now if I change something, I break the whole chain. Like if I change the divisions, now I've only got 7044 here, but there's 552 coming out here, so the whole thing is screwed. It still looks okay because we're not doing anything too specific, but you can imagine I've screwed up this whole process where I'm giving it, these numbers don't line up, the number of inputs, and so the gradients don't line up. And for instance, it's not going to all the way to 1. It's taking this last component. This is what it does when you give it 2 different lengths, a list of 2 different list lengths. It doesn't know how they line up. So it's like after 550 on this side, it's like, dude, I got 200 more. What am I supposed to do with it? I'm just going to take your last guy and scale it by all those increments. So they're all right here, because it was like, I don't know what to do with these other numbers. If it doesn't line up, then I can't do anything with it. So it's important that they line up. This gets even more important when you get into data trees, which we will do in a second. Okay, so I want that to be parametric, not as in flexible, not fixed or dead or static. So how do I do that? I need the number of things in here. You can get that with list length, which is under set and under list, and these things. I guess it's got to be under here somewhere. List. Oh, it's in there somewhere. Maybe it's under. Sometimes I just don't see it. Oh, there it is, list length. Anyway, so that wants the list on one side. You can give it either one of those because they're the same number. Plug in list, and what's coming out, 552 is the number. So I can plug that into my range number. And now it's important to make sure that this is working how you think it's working. Here's where it gets interesting. It's not quite working how I wanted it to work. And this is when you get into like division of zero-based lists and just division. Like, okay, so this is a simple concept actually. I told it to do 552 and it made 553. This is like gonna happen to you all the time. When I divide this curve up and divide it by 4, how many points do I have? 5 points, right? Even though I said 4. That's exactly what's happening here. You've got sort of like an end point happening. I said go 552, it gave me 553. If you need that to be fixed, the typical trick that I do is you could subtract 1. You could just double click on the camera, say -1, and it'll make a little subtraction thing to do it for you. that's the most explicit, easiest way. It gets a little cluttered because you have these extra components. So now it's got 552 coming out. That's kind of nice. If you wanted to do a more clever way, you can right-click on here under the input. You can go to expression. You can say x minus 1. I like doing that way too. And now it's now I'm doing it double. So I try to avoid that unless it's something really, really obvious like the -1 thing, because there's a general importance in readability of your scripts, as in you want to be able to look at it in a week from now and see exactly what you did, and for it not to be too hidden. And that's just you, let alone handing it off to somebody, which you will get to eventually. We have to share scripts. You want there to be readability, and code writing, for instance. There's whole books on the etiquette of code, just like there is with writing. What's that book? Simon and Schuster. Drawing a blank on that. What happens if I talk too much? All right, let's keep going. So I'm going to get rid of what I did there, so we can so it's not doubling up. We still have this issue where it doesn't like that it started with 0, but we don't really need to fix that. It's just because the domain started at 0, and it's like I can't scale it by 0. And you're like, why not? Just make it 0. Whatever. They have different errors. And there's nothing wrong with errors. They're helpful. They're usually something that helps you figure it out. Don't get freaked out. This one is very clear. Cannot scale with factor of 0. So there's probably one of these has failed. It must be the first one. I assume that means like this one, but it doesn't really matter, does it? Okay, so there's a gradient, and we're still just dealing with all lists and lists and lists, and we're doing it linearly. You can't really tell here, but it's just going all in a line, meaning the gradient looks like it's going vertically, but that's just a coincidence of the way that we've patterned it. Is that it's actually going in like a spiral. So this one is slightly bigger than the one next to it, and so on and so on, going in this direction. I think the pattern goes like this, pop, 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 pop. So that's some control. What if we really wanted to control it vertically or in the other direction, horizontally? We need to work in trees. Like if we want to work by floor, that means a number of panels per, say, scale factor. So now we're getting into data trees or sets of sets, or what you call multi-dimensional arrays. So now this is where it gets complicated. And I'm going to just briefly touch on this, not on the remapping stuff, but on lists. Okay, here's where it gets interesting. So far, we've only been dealing with lists, and although they may look like this pattern as we have sort of floors, they're treated in Grasshopper as one long string of things. Grasshopper just sees it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 9, 10, 11, 12. It has no idea where they are in space until you start asking it where they are in space. It's treating it like a list. If we start making it a tree, we're assigning certain ones to certain groups, and you create these what's called branches, which are these things down here. Whereas all my 1, 2, 3, 4s, my 1, 2, 3, 4 is on one branch, my 5, 6, 7, 8 is on a different branch, and my 1, 9, 10, 11, 12 is on a different branch. So each one of these branches can represent, for instance, a floor or a space in the building, and data trees help you control it that way. And now I can assign a different scale factor to each floor individually, one number. So let's tell you how to do that. So first of all, this doesn't give us by floor. It gives us one long list. That just happens to be how this component makes it. If I were to make a component, I'd probably break, and I have my own components that do this. I'll break it up into different floors. If you were to make this yourself, it might be easier that way. You can always flatten it later. Flatten means go from this to that in reverse. We're going to go from this to this right now, whereas then we're going to turn a list into a tree, and that's called grafting, or we're going to use a different way of doing that called partition. Going backwards is called flattening. You can kind of imagine like it has these branches, but if you flatten it, it's just the one long list. Look at down here, the long list. Okay, so we want let's say we want this broken up by floor or by, I don't know, row. Let's do rows first so it's more obvious. Because it already looks like we've got a gradient working by floor. What if we want it to work the other way? We want to use something called partition. That'll break it up into chunks. You could use, so graph will break it up. That's what I've done here. Graph will break it up. I'm just going to simplify this so that each thing, each cell is on its own branch. Remember we talked about branches here, where each floor is on its own branch. This thing is a branch. That's another branch. There's 3 branches here. This thing has made 552 branches, quote unquote branches, where it's got one thing per branch. Look at the n equals 1. One thing on each branch. So 1 cell per branch. I want to do it so there's like 1 row of cells per branch. So I'm going to use this thing called partition. I think it's in here. It's in one of these. I'll just type it in. Partition. And you can see already by the there it is, by the graphic that it's going to turn a list into like a broken up set of lists. A set of lists, what's that? It's a tree. A set of lists, because each set that's broken off now is now its own branch. So a set of lists, or a multi-dimensional array, or a tree, it's all like this. Give me a set of lists. So let's say I want to break this one up, and then you give it the list that you want to break it into, and you give it the size of the partition. Okay, here's where it gets interesting. What's the size of our partition? Right now it's only 2. In fact, it's actually alternating. It's 3 and 2. If I use one of these guys, it'll break it up in its in rows or in floors, because I know that I've got 45 in one direction and 23 in the other direction. At least I hope I do. It might be even an odd number, so we'll see how that goes. I guess 23 is the vertical direction, so if I break it up that way, actually you have to do it the way this is lined up, so this can only work one way, but we can try it this way. So now what's coming out is I still have the same number of things, but now I've got 23 branches with 23 things on each one. So that seems wrong. 23 branches with 23 things on each one. That feels wrong. What if I do it this way? 23 branches. That's really weird. It should be like 45 in one direction, 23 in the other. So strange that it turned out that way. Well, you know what? Let's see what happens. Okay, so here's the other component. I can't now plug this into there. This will blow it up. I'm going to save this now before I start blowing stuff up. It's important to have this saved somewhere before you start going too far, because as long as it has a location, it can save an autosave file. If it doesn't, it'll put the autosave file in some random place and it's hard to find. So I'm putting this in, I don't know, I think I have a file for this workshop. Yeah, so this is like in class 1. This one too, I'll save the Rhino file in the same place. Where is that? Yeah, in class 1. Then you can have them, they work together. So if you open the Rhino file and the Grasshopper together, it'll automatically link itself back. It finds, it's got a unique ID in this, that's been stored in this component. So if that object exists in Rhino, even if you copy it to another Rhino file, it'll still grab it. And even if I copy this to a new Grasshopper file, it'll still grab it and knows that it's here. So I still have it. So that's kind of nice. Okay, so go back to here. I just want to show you doing this wrong first. So if I plug this into here, it's gone absolutely nuts. What has it done? It's taken each like row and kind of multiplied it against this list of standard points, excuse me, and factors. Because now it thinks that every branch, so the component operates on the branch. And before, we just basically had one branch because it's one long list. In the way that you look at this and you like this branch is one list. This is one list, and therefore sort of one branch, which means the component's going to kind of like run once, as in it runs in through every component once. If you start giving it branches, it starts to stop at each branch and run again. So we got it. We're giving it 23. Let me simplify this just so it looks cleaner. It doesn't do anything but make this look cleaner. For each new branch, it's now running against this whole list. So it's multiplying 23 things by 552 things and 552 things every single time. So you get this weird, crazy array happening here. So that means like 23 things against 500 things. So what's coming out is now 13,000 things. So it's kind of funky like that. So we need to break up these guys too. So that gets interesting. So for the centers, you need to break it up the same way that you broke up this one. So if you copy this partition down, and I'll do my drag and my alt thing again, drag and alt. What do we have to do? Then you should be able to, then you want to plug in centers to that, keep the same input, and that goes into centers. Okay, slightly better. Now, the only problem is we have our factor acting weird. So the first list of factors is applied to the first branch, and then the rest is just, I mean, who knows? I can't even explain what it's doing, what's wrong here. But we know that it's wrong because we've got, you can see by the lines, you got a tree, and then a list going in. You know something's wrong there. You should always be double checking what's going in, and hopefully even checking it before you plug it in so you don't blow up your computer. If this whole time we had been lofting these together like we're going to do in the end, it might blow the whole thing up and just be super slow. Right now, luckily, 13,000 lines is not too much for it to deal with, but if it were lofts, it would be really slow. Okay, so we need a different factor for each one of these branches. Like I was saying before, I want to put a different factor for each branch. So here's our branch, 0, 1, 2. And in this case, it's 0, 1, 2, all the way to 23. So I need that many branches. So that means I need a number of these that applies to the number of branches, which is 23. So luckily I already have that number here, which is this one, as I'm already using that. So it's the same number. I can do that. Actually, it may have already worked, but it shouldn't have, because there's another step. But we are now gradienting in that direction. But I should have, I'm not sure why that worked. I feel like something else is also wrong. So it's like two wrongs are actually making a right here. I should have had to turn this into a tree. Still, it's wrong in that, one, it's making, oh no, that's good. We still got this negative thing happening. That's perfect. So it's making 23 things, but we've got 2 trees and 1 list going in. This should also be a tree. And the way to do that is what I was saying is grafting. To turn that into that, you can either graft, or what we did was partition, but graft is the other way, and it'll just turn every single one into its own branch. So partition does it a little more subtly, turns things into branches of the length that you want. This one will turn everything to its own branch. It's very simple. You can right-click on the output and type in graft or grab graft. Okay, now it's working correctly by floor. That's wild. Okay, well, and I still don't get why it's breaking up by 23 and 23. Something's wrong there. That's wild. Well, anyways, so we're giving it this series. What is it? I didn't talk about what's coming out of this series. What's coming out is the steps from 0 to 1, 23 steps that start with 0 and end with 1. I mean, you can see it happening visually, right? But this is what's happening. It starts at 0, as in scale it to 0 or scale it to 0.4. So that's kind of what's happening in the second row. There's 0.4 of the scale, and then all the way to the top, we're all the way to 1. If you scale it by 1, what happens? You're still just the same object, so there's no scaling at all. Up here, scaled by 1, you stayed the same. Though there's still 2 lines there, but it stayed the same. And the next row down is scaled by 0.9. So this thing made this list going from 0 to 1 divided by, what do we say, 22. And it jumps by whatever its division is in between. And it happens because 22 is even, we get this even number in between, so it's actually 0.5 right in the middle there. So the one in the middle is 0.5. All right, so where are we in our oh, I think I had some diagrams for flattening graph. Flatten was you go from this to this. Graphed was you go from this to that, right? That's what we just did. We went from a flat tree to a grafted, where each one is its own branch. Here's the first branch, 0. Oh, and then this guy got all screwed up, sorry, from transferring file formats. Don't worry about that. So we went from a regular list, that, which is this, to this. So you can see it changed here too, where it's each its own branch. Here its own branch, right? And that allows us to have a different factor for each one. What is this thing saying? I don't know. Okay, 45 minutes. Good, we got trying to do some more cool stuff. So what do we have coming out? We've got 552 things coming out. That's perfect. So this is all worked correctly. If it were different, we'd have a different number, like we were seeing before, the 13,000 things coming out. Something was wrong. I know I'm ignoring this error thing. We could fix it if we really wanted to. If we get really sick of seeing the error, we could fix it with our domain here. Remember, we did that domain. We're using the default domain, which goes from 0 to 1. If I wanted to fix that, I could create my own domain. You can type in domain and get the construct domain, or you can type in construct domain. And that's also set from 0 to 1. So I can plug that into the D. Let's say I just don't want it to start at 1. I could change it. Okay, here's a nice little trick. To just get a number, you can double click and type in a number, like say 0.01. That'll make a slider for you that's that. Or I also like doing it this way. I like to do double click on the canvas, quotation mark, and then like say 0.1, and that'll make a little thing for you there. And that at least makes the error go away. If you don't like seeing red on your canvas, which eventually you will get that as a habit, with like, you want to see a canvas all look grays, right? You don't want to see oranges or reds. We don't have any oranges yet. We haven't encountered those, but they do exist. But they're not as bad as red. Okay, there's that. Where are we in our? So that we're nice and clean. Where are we in our list of things we wanted to learn? Let's see. We did patterning. We did data structure. We did modules. We did. Okay, I want to do advanced control, and then we'll do responsive modeling. How much time do I have? No, let's skip advanced control. I was going to do graph mapping. I'll show you that really, really, really fast. You don't have to do it. We're not going to do this together. If we did graph mapping, we could do something much more like that building here, where we can control the numbers that go, instead of just going from 0 to 1 in one direction, we could go like from 0 to 1 and then back to 0. You could do that with, say, a graph. You don't have to do this. I just want to show you, like, let's say it's a parabola or something that goes like this. And we could use that to control it. And what do we need? We need a series of numbers. We can use that and skip the steps. What's now coming out? Yeah, that'll work. Plug this in to factor, and now I've done exactly what that thing had done, only maybe it's the opposite, where it gets, yeah, it's the opposite. We'll flip it to the other way around. Sorry, this is less steps than I thought. You could have followed me if you wanted to. There is kind of, wait, is this the opposite or not the opposite? If the whole is the thing, yeah, actually, it flipped again. Why don't we loft it and actually see it? You could do this if you wanted to. Didn't take too much time. You get the graph mapper and you right click on it and you do graph types and you do parabola. I don't have time to explain exactly what's happening, but because this is 0 to 1, it's querying this. It's querying this like it's fine. Like give me the. So what's the first number here? Is 0.1. It puts that number here, and this thing outputs whatever the number of that graph is. So you're giving it the x dimension, and it's giving you the y dimension. That's what the graph calculator is doing. So give me 0.1 in x. What's 0.1 in x? It is blop. It is, if I take this, show me the result, it is 0.39. 0.39, you can kind of see it's 0.39. Give me 0.14 in x, give me 0.3 in x. Balloon, what's that? 0.3, it's 0.8. So you can kind of see that happening here. And if I change this, 0.3 in x is now more like 0.5. You can see that happening. So this is just calculating the graph for you. Okay, and then you plug that into the graph and that into your factor, and then you control that. Okay, let's do exactly what that building is doing, where we have to have a surface in between. We're going to loft it. Now it's going to get really crazy. We've got to make sure we do this right. What we want to do is loft this curve with that curve. Where do those exist in Grasshopper? Let me see. What's helpful is when you select them, they turn colors. So that's a really useful way of finding like the correlation. So if I select this thing, that turned this green. I got lucky, or I knew what I was doing. I knew that this was that. So I know that this is that part. Which one is the inside one? It's the original hex cells that we made, which is this. So I select that. This has the cells and the centers all coming out at once. If you want just this, if you want to see just the cells, I'll turn this off and I'll look at it like this. Okay, though. So if I want to get a loft, let's get a loft. And I want to do this wrong. I mean, I'm afraid to do it wrong because it might blow my computer up, but I sort of want to show you. Actually, I'm not going to do it. It's going to blow it up. Let's do it. Let's do an example wrong. Okay, what does loft want? Loft wants a list of curves. And it works, again, these components, they work. Every time you give it a new branch, it works again. So it starts again. But it knows to use the whole list all at once. Just like before, we gave it one branch, one list, and it lofted all those guys together. It lofted all three curves together, right? Turn this back on. We want to do that again, only we don't want to loft all these curves together. We want to loft only the one and the one. So it should only be two curves per branch, right? And then loft's going to start over. But okay, here's two new curves to loft. Here's two new curves. If you give them all at once, like for instance, if I just give it the output here, I said I wasn't going to do this, but I'm going to do it anyways. What does it do, if anything? It's now lofting like these whole linear rows. Actually, sorry, it's this direction. It's lofting the whole row in order because as you remember, we're dividing it by floor. It lofts the whole floor altogether because that's the list that you gave it. Let me get my grasshopper back. You gave it a list of, or I gave it a list of 23 things. It's like, I'm going to loft that whole list of 23 things. That's not what we want. We want a list that involves one of the original guys and one of the new guys. So how do we get a branch with one thing on each thing? You remember how to do that, right? It is grafting. To get one thing on each thing, so we want one of these and one of these. This one I've already done it. I've grafted it. If I do that to this one, it might get complicated because it's, in fact, I'll just show you what happens. If I graft this one, I'll simplify it. Now it gets really complicated, and we're not ready for this. We've got two layers, so it's now basically a three-dimensional array, as in we have. But this can be very useful in the future, but we're not going to get into this detail. We've got a branch for every floor. So look at the left of that. Look at the left of that diagram in the yellow. On the left, it goes from 0 to 23. There's a branch for every floor. There's a branch, and there's a branch for every module, and it just happens to be one module per branch. So there could be more than one if you want it to be that way. So it's like basically three dimensions. It's not what we want. We want it to look like this, where you can see there's just one level of branches. And another way of seeing that is with the param viewer. I never used this except to like sort of display this. You don't have to do this if I want to show you this. It's like, honestly, it's not that useful, but you can kind of see that there's two levels of trees. It's like, here's one branch, here's the second branch, and then the last one is a tree, is an array. If you just show one, you can see it's just one level of branches. That's really, I know that's weird, but it's hard because there's so many of them, but you can kind of see it, the difference. This one's breaking up. It's a second layer of branches, so you can see 1, 2 layers. We want this to be one layer, so there's an extra step. The easiest way to do that would be to first flatten it. So like that takes everything out of it. We're back to a normal thing, and then we're going to graph that guy just the same way that we grafted this one, because we started with a normal list and we grafted it, so we can do them both the same way. I can take this and I can copy it down and now graph them both the same way. So I got 552 things here, 552 things here. And if I put them into one component, I'm going to do this in one component before I do it in the loft, just to make sure it's working how I want to do it. Otherwise, loft might blow up if it's wrong. What's coming in now, it knows, because the branches line up, it knows to combine them into, it knows not to like add branches, but to combine branches that have the same index together. So I know it says, give me the things that are on the 0 branch here and the things that are on the 0 branch here, and combine them so that there's 2. So when I give that to loft, it should be happy. So it's still going to be a little bit slow, but it generally did something useful, right? So that's super cool. I'm going to just give you a second to catch up there. Anybody got any questions with that so far? Are you guys like also working at the same time and just listening to me? That's understandable as well. Okay, where are we in our list of things that we wanted to do? I wanted to get into responsive modeling. Okay, responsive modeling. What I mean by that, oh, and I had this whole thing on modules. We kind of skipped the module part. We made a very simple module, but modules are a big part of parametric modeling and about like artistic expression, architectural expression, and parametric modeling plays a big part of that. You can imagine the kind of modules here. There's so much range in what you could do with them. Sometimes it's a very simple module that's just been changed in a very simple way, in this case rotation, and that can create very varied effects or complex effects. Sometimes it's a sort of complicated module that it also has a very complicated transformation in the case of like the Broad or Morphosis Emerson building, or a simple module as a, again, a complex transformation, though in this case it's sort of both the dynamic or complex module that have a very little transformation but has a really dynamic effect if you do it right. Okay, so that's that. Responsive modeling. Let's say if we wanted to do something like this tower, this is, what is this, alpha? Ecom, I forget. And we want to do something that we want to respond to the sun or something. Or do something we want to control this guy, maybe not mathematically, maybe not with a graph mapper, but with like an attractor or something. A tractor might be easier than doing a sun. So let's try with an attractor. So what I want to do is have this open and close based on its proximity to an attractor point, right? Should be pretty easy actually, because all we need is something to change our factor. So I'm going to copy this down. So in the case of, if you guys want to, let's do it like this. These are different inputs to factor. Here we go. So I'm going to just, you don't have to do this, I'm just organizing the script. Here's simple factor, here's graph map factor. So this can go in here. A new factor that I want to do is going to be the attractor. I'll just disconnect this. You don't have to follow all this. Disconnect. It's right click and where'd it go? I lost it. Losing my mind here. Oh, there, disconnect. Graph mapper. You can also do control and then go backwards. Okay, anyways. Where were we? Attractor points. Okay, let's make a point in Rhino. I'll just say point. I'll put it somewhere. You can also do this in Grasshopper. This is actually really cool. If you do it in Grasshopper, if you do a point, if you do it like this and like that, you can set one point. If you set a point, you can change it later. Is that how it works? No, maybe it's not like that. Okay, anyways, let's just get a point in. So you made a point in Rhino. It's not in Grasshopper yet. Let's get it in Grasshopper. You're going to right click on the point, set one point, and grab yours, it's there. If you do, this is just an aside, if you do internalize, I'm just showing you all this stuff to expose you to stuff. You're not going to like retain all this, but you kind of maybe get a sense that it's there. If I do internalize and I select this point, okay, now it's not relying on Rhino. I can just, it's actually in Grasshopper. In fact, these gumballs are now working from Grasshopper, not from Rhino, which is pretty cool. There's nothing in Rhino right now. So if I turn off Grasshopper, there's no point there. Turn Grasshopper on. That point's actually in Grasshopper. I can't even select it in Rhino, but if I select it in Grasshopper, I now have these gumballs. So that's kind of neat because it kind of contains everything in one script. And you can do that with your other inputs by, say, right-clicking internalize data. Now they're stuck in Grasshopper. They don't look at Rhino anymore, which is nice. I can just share with you only the Grasshopper script. And if you want to get it back into Rhino, you can bake it, which is right-click bake on that thing, which is how you get stuff out of Rhino. Sorry, out of Grasshopper into Rhino if you actually want it like fixed in Rhino. What we're seeing now is visualized, right? But it's not actually there. You can't select any of these things. If you want them to actually be in Rhino, you've got to bake it, right click. So if I want to bake these lofts, for instance, I can right click and bake it. It's going to bake it on my current layer. And now I've got actual things in Rhino that I could do stuff with if I wanted to, like, I don't know, add depth or something, but try to do most things or share the file with somebody who knows. But I try to do most things in Grasshopper and wait for baking to the end, but there's times when you'll want to bake. All right, so back to our point. Okay, here's our attractor point. I want these to open and close based on their distance to the attractor point. So I want to measure the distance between that and the module, but I want it to work on every module. But you think of it as a single module. So measure the distance between this and my module, which is this guy. So what on the module can measure to? If we look, what do we have for measuring distance? If I type in distance, there's really just one component, and it looks pretty simple. If I click on that one, what does it want? It wants the first point and the second point. So that's pretty simple. It wants some points. So I got the first point is my one that I just did, and my second point could be the centers that I made already. The hex component made for us. That's perfect. It's already made points for us. This component's so useful. What comes out? A series of numbers. Okay, let's go crazy first and fix it later. I'm going to turn off my loft just to be safe. If that were my numbers and I put that right into factor, all right, first of all, we're still partitioned. Yeah, this is why I wanted to copy it down. Let's copy this down so that we can kind of start over. I'm going to copy this whole thing. You don't have to do this, but it's just a way of organizing this so that if you guys look at this again, you can see. So let's call this tractor point. So we don't need any of the graph mapping anymore. We don't need any of this stuff. We don't need partition. We're going to start over. So start over with me here, and we're back to a single length list, which is going to change each time. And I can just turn off all this stuff. I can select all this and say right click on canvas, preview off. Okay, none of that is valid. I'm only looking at the new stuff now. And we're going to go back to the way we were, which was just only the cells are plugged into scale, only the centers are plugged into scale. It's straightforward, even list. And now we're going to go nuts and plug in our distances. What happens? It goes crazy. Why is that? Because if we look at our numbers, our distance numbers are pretty big. It's still doing it. Where's my point? So for instance, if I move my point around, it'll still change stuff around, which is kind of crazy. Also, the advantage of this point being in, this is actually pretty cool. It's like, this could be like this is like those old school Windows media player, like backgrounds for music. Okay, if you're probably younger than 25, you might not know what I'm talking about. Okay, how do we fix that? I think my friend Dave made a really sweet diagram of that called remapping numbers. Do we have remapping? One of these is, there we go, remapping. Okay, uh-oh, connection. Sorry if my voice is bad. Remapping. Right now we have distance, like, which is a big number, you know, or some number going up to a pretty big number. And what we really want is like this thing, what we call like a unit domain, or for us it's scaling, but it's similar. So we want it to go from 0 to 1. You can transfer the numbers from one to the other, and that's called remapping. So all you have to know is what the end results are. I know my distance goes from something to something, like say 10 to 200, in this case 1 to 10. And I know what I want is from 0 to 1. Remapping is what does that to you, as long as you know those two sets of numbers. Or if you want to go to like rotation, I want to go from 0 to 180. If we were rotating, which we could, we can easily scale and rotate if we wanted to, which would be crazy stuff, but we could. So let's say I want to go, here's my beautiful building, if I zoom in. So I want to use the remap component. Remap. Let's see how far we can get in 20 minutes. Hopefully interesting stuff. Okay, remap. What does the remap want? It wants the values to remap. That's easy. That's my distance. What else does it want? It wants the source domain. Okay, so looking back at this, source domain, that's this thing. The distance, as it goes from 1 to, in my case, like 400 or something. We'll have to figure that out. And then it wants the target domain, and that is the 0 to 1. And we're lucky, it'll save us time. You can see it's already got it set up into it. I can't point to with my finger or my mouse, but look at the default. It says 0 to 1. It's already in there. Whereas this one also has 0 to 1. That's not really helpful. So what we need to do is make a domain. We've done that already. If you remember, let's grab domain. Remember, it was construct domain. Oh God, Shannon, have you been recording?
Yeah.
Okay. Good. Yeah, I forgot to press that. Oh, I can anyways. Okay. Construct domain. Grab that. Construct domain. There's a lot of constructs. It's sometimes easier to just type domain or type the whole thing. Construct domain. That's going to go into our start. Wait a minute. Sorry. Let me do this at all. Sorry. Let's take a step back. What is our source domain? If I go back to this, it wants the source domain, as in, what's this domain? What do we have? What's our start and our end? The way to find that is with a component called bounds. Bounds, type in bounds. That's the first one that says min-max, not the bounds 2D, but bounds. Oh, by the way, I should be in display, draw full names. Oof, that gets to be a lot. Damn. if ever you get lost and you can't tell what I'm doing, you can just type in what my component says. And it'll tell you what it is. So there's bounds. So it'll tell you the min and max of a set of numbers. So if we had our distance numbers and we plug those in, what comes out, it actually makes a domain. So it tells you it's coming out with a domain, and the domain is from 55 to 242. That just happens to be my numbers. If that's my source domain, and the target is 0 to 1, it's going to remap those. What happens if I put those back in? I'm going to get rid of this. What happens if I put those back into factor? What do I got? Pretty cool. It's now attracting to my point. You can kind of see. So let's move this point around now and see if it's really working. Move this guy around. Ooh, yeah, I can see stuff happening. I can see my little guys moving around. That's cool. Parametric modeling, folks. It's like a chameleon that like changes its colors or its scales based on what it's, or like that one octopus suddenly like changes colors. Okay. Sorry, I love this stuff. And then it's the same problem as before. It doesn't like the 0. It started from 0 to 1. We could fix it if we wanted to. We could grab the last fix, which was this, which is now a mess. Okay, here's where that warping space and time is helpful. Warp space and time. Construct domain. What I wanted was this domain that had the like 0.1 to start with. If you could grab yours and move it down, you could do the same thing. If you don't want that error, we don't really care, but I'll just use it just to get rid of the error. So that'll be my target domain, just to make sure it doesn't start from 0.1. And now the error should be gone. Great. Should be able to loft. That should all be still in good shape. Hopefully, I'm going to save first, just to make sure I don't blow it up. Loft. Great. Cool. So basically, it's like closing more as it's closer to the point, because the scale, because the distance number is smaller, and therefore the scale factor is smaller. So like 10 feet turns into 0.1, 100 feet turns into 1. So 0.1 scale is small. And if I move this now, it's going to be probably really slow because I'm lofting every time. So that's kind of dangerous. So yeah, now I'm frozen. So if you want to do stuff like that, you can see I have this profile turned on. You don't have to do this, but it takes a second and a half to run this every time. And that's not even including the visualization, which is another couple seconds. So yeah, so that's that. All right, so we got 15 minutes. There's our attractor point. That's cool. I'm gonna keep my loft off just because it's, oh, by the way, there's previewing off. That's one thing, but it's still working if you preview off. If you do enable, that stops it from working. So it's not doing anything. It's not dragging your computer. It doesn't slow anything down. That's really helpful when you start to get heavy components and heavy canvases, and you just want to work on some things. You know, like for instance, if I have that on, even if it's not previewed, it's still going to slow the thing down. So this way I can work, I can play around and get immediate feedback, real time, super fast, and not have to worry about the lofting, which is really not super important for me to be playing with it right now. Well, there's ways to make this faster if you made the surface a different way, like made it out of, say, meshes from points or something, it might be faster. Because loft has to take some extra time. Also, loft is it multi-threaded? No, no multi, don't worry about that. So I'm going to turn mine off, Control E or enable or select it in middle mouse button. And this guy on the right, enable, disable. Okay, next step, where are we on our list of things to do? What about analysis and feedback? Critical part of parametric modeling. One of the beauties of it is you can get real-time feedback. You can do complex analysis. You can really understand your models in more detail with through parametric analysis. So let's do something really simple. We've got 15 minutes. We can do this and probably get to exporting your Interop as well. super fast. No, actually, we may not be able to. It might just be this, but this will be fun. What if we wanted feedback? What if there was something about this component that I wanted to see, like in color, to visualize what's happening? In this case, the actual behavior that it's doing is very visible because we happen to choose something very graphic. But what if it was something that was not very graphic, like a thickness or a very slight change in proportion or a planarity or something? I wanted to visually show it, like with colors. You can do that by, there's all these things under display. Preview, you can preview, say, you can change the color of something. So if I grab, like, say, custom preview, or if you double click and say preview, you get this custom preview. So if I take these curves, let's say if I take the ones that are, I'll just take the original hexagon curves, the very original ones. I can change all their colors by this material. There's a default material set in there. I can use a swatch, type in swatch and change it. You don't have to do this, I just want to show you. Now I have this color that I can change. I can change their color. And there's some pretty cool components that work with lines. You won't have them, but they're human. And I like those a lot. I use them a ton because they'll change the line weight. You won't have this, I just want to show it to you. This will change not only the color, but the line weight. And that can be very useful when you are visualizing things. Like if I want the line weight to change, like for some reason, like each one should be a different line weight, I can change the line weight. And this is really not heavy on the processor or the graphics card because it's just a line weight and it's not actually like a physical form. So that's really nice when you want, instead of like piping it, for instance, which is a much heavier, much heavier object. Okay, but you don't have that. We'll use custom preview. Okay, let's do this really cool and very common way of coloring things by analysis. We're going to use what's under parameter, under utility, under input, and it's the gradient. So you can also just type in gradient, and that'll give you this range of colors. Okay, so and if you right click on gradient under presets, you can get all these different kinds of colors. I'll often just like grab one. I don't know, like I can just grab the original one and like change. You can change the colors. Maybe if I want to change mine from like purple, I don't know, it's going from like pink or something, light pink to purple, who knows, man. Maybe a darker purple, darker something, maybe a stronger pink, whatever. That can be your gradient. Okay, so now this is going to do the same thing that Graph Mapper did, in that you've got your x-axis and your y-axis is the color. So I'm going to give it an x from 0 to 1, and the y is the color coming out. Whereas before we gave it the x and the y was a number, now x and y is a color. And this is kind of weird, unfortunately, it's kind of dumb in that it doesn't work the way the Graph Mapper does, and that it just knows it's from 0 to 1, and you can change it if you want to. This wants you to set the beginning and the end, as in the parameters of the x-axis. It's default from 0 to 1, which we'll leave it at, because we've remapped our numbers from 0 to 1. So we like cleverly already have this already working for us. So we can just put our numbers into here. That'll output some colors for us if I show you just to look what's coming out. It's giving us a bunch of RGB colors, which are kind of like actually represented as actually literally 3D points, but it knows that they're colored. If you give it to a color component, it knows that they're colors. If you give it to a point component, it also knows that they're points. That's some funny stuff about like variables interacting with each other. So there's actually all the points, which is super weird. But if I give it to the materials over here, it will now change and we'll get this heat map of colors based on the closeness. So it's pink on one side, and I feel like this doesn't visualize clear enough. Maybe it's like even more red or orange or something. Yeah, how about that? I like pink better. There's pink. Great. So I can move this now, move my point around, and my colors change, and my opening changes, and I'm golden. Just to show you in more detail, or show you again what happened. Super simple. I just added a color gradient. And because of the way we set everything else up, we already had it. Because we already remapped. It's like all we have to do is plug it in, plug it in. It's like super simple. Whereas normally you like to go through the steps of remapping or using your lower and upper limits. Conversely, you could give this, you could change this lower limit, upper limit to be your lowest distance and your highest distance, and the parameter could be the actual distance, and it would get the same result. So that is analysis and feedback. So you got immediate feedback on what's going on here. Where you can see it colored. You could also color your loft. If we do our loft, so I'm gonna turn my loft back on, and it's gonna go nuts first. And I'm gonna put it in here. I'll do it wrong first, just so you can see what's happening. That might have been a mistake. I should have saved. If I escape, it might. Yeah, sometimes escape works. It kills it. It stops it. Sometimes it doesn't, depending on how third party the component is. So I was able to escape and stopped it because I plugged a tree in and a list, and it's multiplying the two together, and you guys know what happens when you do that. So I'm just going to lock my solver, middle mouse button, lock button, or solution, and disable solver, right click and lock solver. I'm going to turn this off again. Sorry, I'm going to unplug this. I have my solver back on. Okay, what's coming out of here is a tree with each thing's on its own branch. What's coming out of here is a list. You can see that by the shape of it. I want this to be back onto a list. Do we remember how to do that? Do we remember how to do that? What is that called? That is called flattening, where you start from a tree, you flatten, it goes back to original list. And this was called grafting. Okay, so we want to flatten this guy. You can do that. By the way, there's components that do the same thing. I never use these, but you can do this. You can do flatten if you want. If you want to like really see, that speaks to like visually seeing what's happening, but I often just do the right click on the output node and say flatten. So let's make sure I got what I've got. I know what I've got. Yeah, now I've got a list that's 552 things long. This thing's 552. That should work. Let's color it. Boom. Now I got my lofts colored. But now I can't really move the point around as much because the loft is super slow. But you got something super cool. It looks like it belongs in LA, where I am right now. Yeah. Okay, last thing. We got a few minutes. We want to do interop. Not the interoperability you think. There's lots of ways to do that, though. We've got construe internally we use. We've got like Mirar or Swarm, which will put it to the web. If you want to interop with the web, construe will send it to Revit or other things. What if we want to get it to Excel? And that could, then we can go anywhere we want with it. If we're doing it in a custom way, the construe does that for us in a much easier way. But we can use TT Toolbox. Where's that? This one, and it's got these great Excel components, which are over here. There's some other Excel components. Let me type this in. Who else has Excel? 2 or 3 other people have Excel. Who is that one? That's Lunchbox, right? And it is buggy and doesn't work as well. I'm not like plugging TT tools or anything because we're also using Lunchbox, but these work so much better. So this is super simple. What if I just want like all those elements to go to Excel? Like I want those numbers to go to Excel for some reason, because maybe I can get them into Revit as adaptive component parameters or something, or I could change them and bring them back in, perhaps. That could be another thing. If I want to say write to Excel, we'll do this really dumb first because we only got a few minutes. So I go to my Excel under TT Toolbox, I can do write to Excel. What does it want? It's got this run question mark. What that wants is just like a button, because it wants a button that says true or false, and when you like click it, it'll run it. So you can just use the button, type in button. That's a cool component. Right now it's set to false. So if you hover over run, it says false. If I say true, it'll run, but it's got nothing in it. So it's got all these inputs: worksheet, column names, row names. You got options if you want. Columns or rows, like how is it transposed, and then data to write into columns. So the data, let's say our data is these numbers. Let's say it's the original distance numbers, which are here. Doesn't really matter. I'll just show you how this works. Here's our data. It doesn't like me. What's wrong, buddy? Could not find load file or assembly. Let's see what happens if I just press it. Uh-oh. Could not find. Let me see the whole thing. Errors are good. Help you get through things. I haven't used this in a while. Oh, that's weird. Usually they come out. Oh, this is a deeper problem that might be my own versioning issue. Hopefully you guys don't have this problem. I just said they weren't buggy, and I think my version is my version's out of date or something. All right, let's try the lunchbox ones. Fine. Excel, right. It should be super easy. Do the same thing. Just so our data is here. What happens if I press it? It should bring up an Excel book. Maybe not. Sometimes it wants an open or running one. Oh, it actually wants column headings. Oh man. Okay, I'll just give it one because that's this is distance. You don't have to do this. I can just show you. Let's see what happens now. Run it, baby. Show me the money. Show me the money. Simon's leaving. See you, Simon. Well, it's nice that we got through almost everything without a fail. Let's call that one a fail, though. Did not save that. I wonder if this wants to be. Oh, I wonder if this wants to be a toggle. Let's do this. Instead of a button, we want it to be true forever. Ooh, it really is not happy. All right, interop is a fail. Let's put a X through that. No, I'm just kidding. That's a big red. Use construe. That's the point there. Use construe. Besides that, let's be happy with our. Funny, none worked. Whatever. Whatever, Excel. I didn't like you anyways. Let's stop there. At least we got a colorful chameleon building, and I hope you guys have some comfort with it, with Grasshopper now that you can play around on your own. 2 hours is not enough time, but it should have gotten you somewhere. Come back and ask us questions. Jonathan and I are pros, and we love to help people, and even just teaching gives us ourselves new ideas and is stimulating. So it's nice, and we just love interacting with our.
Definitely. Anything we can come up with using these tools is always pretty fun, no matter how weird or complex or simple it is.
Jonathan's done way weirder stuff than this.
Yeah, this is pretty normal in my eyes. But anyway.
So any questions? We caught up. You guys, would you benefit from having this file?
I think you should share regardless, just to make sure everyone has something to reference back.
I'll put it on the Slack channel. Anybody have any questions? Anybody's mic work at all? All right. Shannon, happy?
I'm so happy. Yeah, I just shared a YouTube playlist link. This has our workshops from last month on it, and I'm also going to put this one up on it as well. But yeah.
Where did you share that?
Oh, on the Ring Central chat.
Ring
Let
Central.
me also do Slack as well.
Okay.
Yes. And then I forgot to mention that all the classes have AIA credit as well. I'm waiting for HR to send me a survey link so people can fill out surveys to get AIA credit. So once I get that, I'll resend it out to everybody.
Cool. I have a question. Since we're bored and we're sitting at our homes, I'm just curious, did anybody have like ideas in their head for projects that they wondered if it was possible? Like, I have a suspicion some people do this kinds of courses because they like had something they wanted to do. Andre, yes, exactly. So what Andre's asking, what does Unroll do? Yeah, it'll take a form and flatten it so you can put it on a sheet and cut it, laser cut it. But beware, because some Unroll commands will straight up flatten it and distort it if it wasn't flattenable in the first place, if it wasn't developable. So you got to make sure that it is developable. Other ones will give you an error if it's not, which is useful. You have to be good at like making sure it is planar, as in able to be cut, or break it up appropriately. And speaking of weird stuff, that's what Jonathan's a pro at. All that Mark Forn stuff that is complex curvature but made up of sheets. You have to know how to pattern it so it can unroll into a flat thing, right?
Yep. So you need to learn how to unroll anything else too complicated. Can you mock the definition, see if it works for this?
Yeah, so I'll do it real quick. If we did this, let's say grep and unroll. Which unroll? There's a bunch of different unrolls. Which one is this one coming from? I forget. This is Lunchbox. Okay, so give it the grep, and it's unrolled that. You see it on the ground there? And it's asking if you want them joined. I don't know. Yeah, it's just a matter of what this is. So there's your unrolled shape. Now, if this were distorted, it might still unroll. I forget if this is a smart one or not. No, it doesn't distort it. How do I distort this?
For this particular scenario, you could just do that, like unroll, like you could take those.
If it were distorted, it might still unroll it for you.
Does this work?
Yeah, this would be wrong, but yeah, this might blow up, but let's see. Well, first of all, it puts them all in the same place. So you gotta, that's fine. You just have to do a move to spread them out. We're not nesting it. We're not nesting it yet. But yeah, so actually this has done it smartly. It's broken it up into pieces for each one. Let me go back. And let's just say if I do this by X, I just want to show you what it looks like, what it's done. 10, factor of 10. Okay, so it's, what did I do? Oh, I didn't make a series. Damn it. Need a series. Step is 10, count is list length. Doing this really messy, sorry. And there's your factor. Boom. Okay. So here's all the pieces, and it's kind of broken them up, which is complicated. I broke them up the way that I moved it, that it would keep them close together. But the problem is each piece is planar, each one of these like little quads is planar, but not each one together. So it's a slightly extra trick to unroll this as a piece. But yeah, that's just another step, but it's possible. Does that make sense, Andre? And then the next step is nesting.
Yeah.
Ooh, it's a lot of pieces.
There's a Grasshopper plugin got released some while back called OpenNest, and it's like a free nesting software if you can't afford Rhino Nest or just don't want to pay for it. It's a really great add-on to what you're doing right now. You can just take all these pieces and nest them to a sheet your size, and Well, go ahead and laser cut.
That's great.
Very
Does
useful.
it use Galapagos?
No. It's
Do you use Galapagos, Jonathan?
no. It's like, do I use Galapagos or does the software use Galapagos?
No, does the software?
Oh no, it doesn't. It's its own little plugin. It was written away from Galapagos or anything like that. It's just
Okay.
I don't know. It's kind of like a black box in my head, but very useful.
Okay.
Yeah. Open Nest.
Open Nest. I could use that in the future.
Yeah, definitely.
Okay. Anybody have any other questions? Any project ideas you've been mulling over? Yeah, exactly. So you're asking about if you want to flatten this thing. It's an extra step to keep them together. Okay, so that would be what's coming out. If I look at unrolled, if we do this a different way, and we say join unrolled, we want that to be true, total, then it will keep them together. And now when I move it, I need the branch count instead of so I need to move it by each. Oh, kept it together, great. Okay, so actually that should work the same now. So we'll just plug this in to here. That might be better. This should work actually, like this. So yeah, kept them together. There you go. And there should be like a gap. Yeah, there it goes. That's weird, there's no gap there. One of these edges should be broken. There should be like a little gap because it's not perfectly planar. But I'm not seeing that, which makes me worry that it unrolled it. Oh, no, there it is. There it is. So they're actually very close to being planar. But so you could cut it like this, and when you join that edge, it'll then take its shape in 3D, right? So it just breaks the one edge, which is actually really smart. Surprised how close to planar they actually are. Thought that works off. I guess they're small enough that they're handling this curvature easily. So yeah, does that make sense, Andre? Yeah, and the next step is to nest all these individual pieces. Yeah. Anybody else project musings or things they were wondering if it was possible? Look at all those pieces. Yeah, right, Andre, that's what Jonathan was talking about. We need to nest it. So the next step is nesting, which you would do with what Jonathan was saying was open nest is one way. Or you could do it yourself by like kind of partitioning it and stacking them in rows. Or you can make your own nesting with Galapagos, or actually use Rhino Nest, which is a proprietary software that has a cost, but it's actually really, really good. It's worth it if you're doing this more often. So yeah, that's just the next step. That's more advanced parametric modeling. That's a cool idea. So you're saying not nesting according to sheet, but nesting according to folding edge. Oh, you want to unroll them like connected to each other? Yes. Okay. That's getting even more advanced. And for that, I use a tool called Pepakura. It's not in Grasshopper. I mean, you could figure it out here if you join these and it would get messy. You could probably figure out a Galapagos thing that finds the correct organization to unroll them so they don't overlap. Because the problem is, if you join this all and unroll it, they're going to overlap each other, no matter what sort of ribbon you go in. But you could join them in ribbons and unwrap them, but Pepakura is even smarter in that it figures out the best way to unroll the whole thing so that it's still in either one piece or relatively low amount of pieces. Let Let me find it for you. And then it'll make the pattern for you. Though in that case, you have to leave Grasshopper. So I think it's called Papakura. That's a district in Tokyo. That's not what I meant to do. I just used it last year for something that's really useful. Yeah, this is it. I've yet to see a really, really smart algorithm. And actually, Jonathan could probably speak to that. Do you know of any really great ones that would unroll this whole thing for you?
The whole thing as like a flat sheet.
Yeah.
There's a, well, I know, I think it might have been either through Rhino Nest or through open nesting, but essentially that specific surface you have there is technically like one piece of paper, right? It's a continuous surface, and you have a bunch of things on it. Technically, I think the way it could work is that if you manage to unroll the surface, you could unroll all the stuff with that surface. And I think there's an unroll component. I can't remember which plugin exactly, but there's an unroll component that lets you unroll things that are on top of the surface. So imagine you have a surface that's really funky, but it has a pattern on it. You can unroll that funky surface, flatten it out, and the pattern will go with it. That is very much a thing. And I think actually Rhino's command of unroll lets you do that. The unroll command itself.
I think that still keeps everything like disconnected though. You still have like individual pieces, right? In that case. Like if we want something that keeps like a number of the hexagons still linked together.
Yeah, that's what I'm trying to get at. Like I think,
okay.
I don't know if you have this. Yeah, actually, openness has what I'm talking about. I wonder if there's any other one I can demonstrate.
Andre, to your question, the hexagon things are not planar and they won't be planar because of the surface is double curved. You could rationalize it and make them planar, but that's a whole other thing. I'm trying to do it. We're trying to create this surface with what we have. You can make it out of triangles or something though.
Oh, okay.
Yeah, you won't be able to get these to be planar.
I think
unless they're going to have edges that don't.
Sorry, I didn't mean to interrupt. But do you have pufferfish on your tower?
Yeah. Mm-hmm.
Yeah. So if you go to pufferfish and you go under surface, I believe there's one that says unroll surface. Unroll polysurface. Unroll polysurface. You see that one?
Oh boy. No, where is it?
Yeah. All right. I would just type in just to make it life easier. Unroll polysurface. It'll show up a lot faster.
Oh no, you might have a different pufferfish.
He's on space. No poly surface thing.
I might have an old one.
Oh man. Anyway, well, my point was.
Anyways, that's another one. Go ahead.
It was gonna do what they were asking, where like those panels. I know they're not planar, but it'll flatten out the surface, and then those panels will flatten out along with the surface. So, in theory, you'll get whatever you have in 3D, but flat in 2D.
Yeah.
The ability of doing that.
So there's ways to mess around. There's things to play with, Andre. You got some homework for yourself.